Okay. Okay, so we can put these three traces. Let me see. Yeah, horizontal traces. We can put these three traces together to get our contour map. So we can just overlay them on top of each other, and we will get something as you see here. Okay. Let's make sure we answered the question being asked. So it says sketch the contour map of this. Okay, and I think we did that, and we'd have to put all three of them together, but we'll get a graph like this. So now, okay, let's take a look at this example 7. And I'm going to just copy and paste instead of get rid of stuff because we might want to reference this. So I'm just going to start example 7 on a new page and start it here. And we'll go like this. Let's go back here. Okay. So now this one says we want to look at the contour map of a linear function. So when it says contour map, all we're doing is basically finding a trace when we fix our z or we fix our outputs. So when it says contour map, we just fix the outputs, and we want to consider when the output is 0, when the output is positive, when the output is negative. That's where we are so far. Okay, so this one says sketch the graph of f of x comma y equals to 12 minus 2x minus 3y and the associated contour map with the contour interval. So we want to go, I guess, from 0 to 4, or we want to have an interval of 4. Let me look at something really quick. Oh, in steps of 4? Okay. Okay. So when it says the contour interval, we're just talking about, between tick marks, we have 4 units. Okay, so let's look at this. Okay, so looking at this, let's see, sketch the graph. Now we have f of x, y equals 12 minus 2x minus 3y. So let's just replace the f of x, y with z, and so we'll say 12 minus 2x minus 3y, we're going to set that equal to z. So then, if we get the x and y's on one side, x, y, and z on one side, and the constant on the other, they should look familiar. So then, I'm going to add the x and the y, so I'll get 2x plus 3y plus z should equal 12. Okay? Let's see. Okay. So we should be able to recognize that this is the equation of a plane. Again, so on exam 2, and more than likely on the final, I'll allow you to have a sheet you can bring in, a formula sheet. So you can have a sheet where you put all your formulas and your graphs and things. So you should have something that has like the images, and so we should kind of be able to see that this should give us a plane. So then if we wanted to graph this plane in the 3 space, we could just plot the intercepts. So the x-intercept, the y-intercept, and the z-intercept. Okay, so this is a plane. So let's just say that this is a plane. And so we're going to plot the intercepts. So if we're plotting the x-intercept, normally when we find the x-intercept, what do? We set y to 0. So in the three space sense, we would set y and z to 0. So let's see if we can find the x-intercept. So then if we set y and z, we want to set both of those to 0. Let's write it a little bit better. So we're going to set y to 0 and set z to 0. So then when both of those are 0, we'll get 2x equals 12. So the x-intercept should be, what is that, 6? And then let's look at the y-intercept. Okay. So then we would set x to 0 and set z to 0. So when both of those are 0, we'll have 3y equals 12. So then y equals 4. And then for the z-intercept, we would set x to 0 and y to 0. So then we get z equals 12. So if we wanted to sketch this plane, we would just plot these three intercepts, and those would be, those will define our plane. We have 3 points, so we can, find the plane that connects those three. So let's do this. And we're just going to do a quick sketch. So we'll go here. Now, we're attempting to do it in 3, which is okay. You can approach it or try. Let's go. What's the best? Let's go like this. Okay. So then let me see. X goes to 6. The y. So normally when we do this, I think because it has to go, for it to be the correct orientation, it has to curve from the x to the y. So yeah. So this needs to be our positive x. This needs to be our positive y. And this needs to be our positive z. And then, we could also go down, but I'm not going to draw those just yet. Okay, so then we need to go 12. Let's just go 12. Let's see, 1, 2, 3, 4, 5. So we can do a 6 and go by 2s. Let's do 6 tick marks and go in steps of 2. 1, 2, 3, 4, 5, 6. So we're going to get rid of that and that. That one actually is okay because it's not. So we just want to extend this by 1 like that. Extend that by 1 or more here. So then we got 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. And then we're just going to go 2, 4, 6, 8, 10, 12. Okay, so if we're plotting these intercepts, so x is 6, so we would just come here on the x-axis, and there's going to be our x-intercept. And then y equals 4, so we're here. And then z equals 12, and we're here. And then we just want to consider the plane that contains those three. So we're like here, here, and here. And then, it extends out in all directions. And I'll just kind of do so it's the plane that contains this triangle. And again, it's a plane, so it just goes on forever, but essentially that's what it is. Okay. I guess we could, yeah, let's try. So